My special guest this week is Dr. Timothy Mousseau, a professor of biological sciences at the University of South Carolina. He currently also serves as the Associate Vice President for Research and the Dean of the Graduate School at University of South Carolina. Dr. Mousseau's past research has focused on the genetic basis of adaptations to changing environmental conditions in wild animal populations, and he has published more than 120 scientific papers on this topic. For the past 12 years, Dr. Mousseau and his colleagues have been studying the ecological impact of the Chernobyl disaster on wild plant and animal populations living in the so-called zone of alienation surrounding the destroyed nuclear power plant. Dr. Mousseau is considered one of the leading world authorities concerning the impacts of low-dose radiation on natural ecosystems.
I just got back from 2 weeks in Chernobyl, and we found, again, three out of 500 birds that had very, very large visible abdominal tumors.
Oh.
And again, that may not sound like a lot, but that's an incredibly high frequency for that kind of growth. And so our plan in the coming years is to start taking biopsies of
these and making the diagnosis. So now also, Tim Mousseau, you've also found that a high percentage of the birds have smaller than normal brains. Is that correct?
We just published those results a few months ago in PLOS ONE. We did this survey of about 550 birds last summer, and we took measurements on the brain sizes, the head sizes, and inferred the brain sizes from that for birds living in high, medium, and lowly contaminated areas for over 40 different species. And we found that on average, across the community, the birds living in the contaminated areas had a 5% smaller brain, reflecting impaired neurological development. This has been reported before as a common response to radioactive contaminants.
Yeah.
It hadn't been reported in birds. But what made this observation particularly interesting was the fact that when we looked at birds in the contaminated areas, we found that the birds with the smaller brains were less likely to survive to the second year. So there were the birds that were older were the ones that had the larger brains, again indicating that there was some cognitive relationship to this smaller brain. So the radiation was affecting the neurological development, which was directly influencing survival, probably as a result of their ability to avoid predators or find food.
Well, now, how can we relate that to everything you've just described, Tim, the genetic abnormalities, the deformities in the birds, the small brains, to the human populations, specifically in Belarus and the Ukraine? I do know from the Chernobyl report that you helped get published by the New York Academy of Sciences that there are homes full of very deformed children. And in fact, I've seen a film called Chernobyl Heart that documents these children, grossly deformed children, in very heavily contaminated areas, number one. Number two, I do also know that I think in Sweden and Norway and Ukraine, there seems to be, amongst children who've been exposed to radioactive material from Chernobyl, a lower than normal IQ level, and also we all are seeing, a high incidence of malignancies amongst people living in these highly contaminated areas. So can you extrapolate directly from your animal experiments or observations to human populations, Dr. Timothy Mousseau?
Yeah, it's something we try to avoid, but it really, it's just so overwhelming. One of the advantages of working with wild populations of plants and animals is that you don't have to worry about some of the confounding factors that you have in human populations. when these reports, these statistics associated with birth defects in humans and genetic effects in humans and infertility effects and IQ effects, these have all been relatively well known for a while, but the traditional interpretation has been that these are the consequence of environmental factors like alcoholism and smoking, as well as immunosuppression resulting from the stress of the disaster, rather than the direct consequences of radiation. But as you know, birds don't drink, they don't smoke, they don't get depressed, as far as I know, at least. Anyway, and so when we start to see parallel patterns of what appear to be responses to the contaminants, you can't help but think that there must be some direct relationship with the human populations as well.